So the reaction that we will be talking about is chromate oxidation. Chromate oxidation is a reaction that occurs using chromic acid as a reagent. Now, chromic acid is a strong inorganic oxidizing reagent used to oxidize many classes of organic compounds, mostly alcohols. So if you place a primary alcohol with chromic acid, it will be oxidized to an aldehyde, which in turn will be further oxidized to a carboxylic acid, since, as we mentioned before, chromic acid is a very strong oxidizing reagent. Now, if we placed a secondary alcohol with chromic acid, the secondary alcohol will be further oxidized into a ketone. Now, what are the steps of this reaction? Suppose we have a secondary alcohol, which is 2-propanol in this case. So imagine mixing 2-propanol with chromic acid. The first step that will occur upon mixing these two reactants together is the nucleophilic attack of the alcohol's oxygen atom to the chromium atom. As a result, the pi bond between the chromium atom and its oxygen will collapse. Now, to better understand every step in this reaction, the mechanism will be presented in a different way. The first group represents the chromic acid. Note that the other oxygen is attached on the chromic acid's back for simplicity. And the other group represents the 2-propanol. Of course, every hand represents one bond. And as we mentioned previously, one of the lone pairs on the alcohol's oxygen atom will form a bond with the chromate atom. طيب, the product هلا is probably a chromate ion, and the oxygen on the alcohol now is in its protonated form. The second step is the protonation-deprotonation step, in which an internal proton transfer will occur where one of the hydroxy groups on the chromium will reach for that proton of the oxygen, giving the electrons back to the oxygen. At the same time, the deprotonated oxygen on the chromate atom will donate its electron back to the chromate to regain its stability. The product that will be obtained now, the products actually, are the chromate ester and the water molecule. Okay, so over here we can see how the hydroxyl group on the chromic acid is bonding with the hydrogen of the oxygen on the alcohol and leaving the compound. Now, the third step is the beta elimination step. In this step, the oxygen atom in the water molecule grabs the hydrogen and leaves the electrons behind. The electrons are then collapsed toward the oxygen as a pi bond. Now, the oxygen has too many bonds, so eventually it will collapse its bond with the chromate atom. This will result in 3 different products. The first product is propanol, the second product is chromite ion, and the third product is the hydronium ion. طيب, so هون we can see how the oxygen atom in the water molecule is forming a bond with the hydrogen, and how the oxygen atom in the ester is breaking a bond with the chromate atom and forming another bond with the beta carbon. Like, and as explained before, the first product to be formed is the chromite ion. We can see the double bond O. Here is the propanol. And the third product is the hydronium ion. Okay, so that's it. Thanks for watching, and we hope that we'll see you around on campus. يعني.